So our next speaker or next workshop will be presented by Sreelaxmi Chakkadath. And Sreelaxmi is a data science master's student at Indiana University Bloomington. And she also works part-time as an associate instructor, teaching undergraduate students about SQL and basic statistics in R. And prior to this, she worked at Accenture as a senior data analyst for 4.5 years, where she worked with US healthcare data. And Sreelaxmi will present the workshop Basic to Intermediate Level SQL. So we're very excited for your workshop.
Thank you, Julia. Thank you for the introduction. And thank you, Dr. Parisa Kambosh, for a very informative session that was really helpful. Structured query language, that is the topic for today. It is used to store, manipulate, retrieve data from or in databases. SQL is majorly used on relational database models. That means the data would be stored as tables, rows and columns. A table is a collection of data entries, consists of what we say as columns, are referred to as fields or attributes in some standard textbooks, and rows or records and tuples. So why data science, like SQL, is important for data science? So if you check the job listings, job postings on various social media, like various websites, you'll see that after Python, SQL is one of the most frequently used language in data science or data analyst positions. SQL handles structured data as opposed to unstructured data. Structured data is nothing but data that is stored as columns and rows. And we can manage a large volume of data with it. And another important factor is that SQL can be easily integrated with scripting languages like Python. While using Python, we can actually use a SQL in the form of SQLite 3 along with the Python coding language. And SQL is declarative and it is easier to learn than the other programming languages. So I would be using PostgreSQL for the demonstration. I guess the link for installation and how to install PostgreSQL has already been shared with you. If not, you can follow along with me and later download with the provided links. So if you have PostgreSQL installed, that would be really great. So just an overview about tables. So this is how a table would look, and this is a column. Like this has 1, 2, 3, 4, 5 different columns. And this is a row or a record or a tuple, like yeah. So relational databases, when you look into like SQL workshops, you will see like small tables with a few columns and few rows. But in real world data the data that SQL would be dealing with would look more like this, with many number of rows and many number of columns. The data that I'm using here is the IMDb movies data set from a Kaggle competition, but I'm not using the entire data because it would be a bit difficult to present and show. So I am using a few columns and few rows extracted from the IMDb data set that is available in Kaggle. So yeah, so while talking about SQL, it is very important that we talk about DDL and DML commands. DDL commands are used to define data structures. That is to create a table inside our database, and you can alter the table based on something. The ML commands, data manipulation commands, are used to manipulate data that that we would be dealing with data itself, as in inserting data into the tables or updating data from the table or deleting data from the table. So this part will not be discussed deep in this session, but the basics will be covered. So this is the syntax for a create table, create table command. Create table, you can put if not exists because we don't want to overwrite a table which is already existing in the database. Table name, you can give a table name which is relevant to the data that you're storing. Avoid giving table names like XYZ and all because the table name would be very important while working with the data. And inside parentheses, column 1, data type and column constraint. I'll be talking about column constraints later, but column 1 is the name of the column. Data type is the type of data that we'll be storing in the column. That is either text or integers or floating point variables, etc. The source here, PostgreSQL tutorial.com, is a very useful website if you are starting to learn SQL. All of the syntaxes that I am describing here are there in that source. You can check it out later. So yeah, this is an example of how it would be used. Create table IMDb movies, and IMDb movies is my table name. IMDb title ID is my column name. Text is the data type that is IMDb title IDs would be of text data type. And primary key is a constraint which I will be discussing later. And it's not necessary that you need to give the constraints all for all the columns. You can give only for the necessary columns, but this is how you create a table inside our database. Now, I will be switching to the tool, and I believe that the script was provided for this workshop. So I would like you to utilize the script. So I'll be moving onto the tool. I hope that the tool is visible now. Now I am on the screen for tool. I hope that the tool is visible.
I don't think I see the tool right now. I'm still seeing your slides.
Okay. Sorry about that.
Okay, great. Yes, now I see it.
Yeah. So what once if you have already installed PostgreSQL and pgadmin, yeah, it would look somewhat like this. Well, not exactly. Your query window would not be open, so it would look somewhat like this. So what I want you to do is open the server PostgreSQL and right-click on the databases and create a new database. So we need a database in order to create our tables. So type in your database name. I am just typing in as with SQL, and when you click on save, it will get created. It's easy as that. So if you can do that, that'd be great, which I have already created with SQL database. And next thing what I want you to do is that click on a new query window. While on the with SQL, make sure that you are on the with SQL database and click on the new query window. And I would want you to run the script that was provided. So that contains all the create table and inserting values into the table queries. So I would want you to copy and paste the whole script to this new query window and run the whole thing so that we have the necessary tables and the data inside those tables. Well, okay. Now, moving back to our the slides. So this is a create table command, which is already present in the script that was provided to you. So you can run the script, and this is an insert command. So a create table command will only just creates a skeleton of a table, like what are the number of columns and what are the data types of those columns and how many columns are there, and with the table name. So actually to insert data into your tables, you will need insert into table name, column 1, the value inside column 1, value inside column 2, etc. And yeah, like this you can insert into. So the insert command is also provided in the script so that you can insert those values and have a table for the rest of the session. So this is somewhat how it would look like: insert into IMDb movies, then values, and inside the parentheses all the values that are required inside our table. So this is an insert into. There are these are just the basics of how to create and insert a table. I am not going into the very details of the constraints and the other stuff, because the main focus of the this this workshop is the data querying, which is used in data science. So a primary key constraint that we saw earlier, that we declared a column as a primary key in our create table command. Primary key is something which uniquely identifies each record in a table. For example, if you are an employee of an organization, you would have an employee ID that is unique to only you. No other employee in the organization would share that ID. That is that ID can be used as a primary key, and it can never be null. You cannot ever not have an employee ID if you're working in an organization. So a primary key is something which is used to uniquely identify a record. So it can never be null and it is always unique. So in our case, IMDb movies, IMDb title ID is our primary key. And if you look, every primary key is different from each other, and they would never be null. The primary key can never be null. Another concept is a foreign key. A foreign key is used when we have to deal with more than one tables. If we have to join one table to another, we use this foreign key to join to the primary key of the other table. For example, this is the overview of the databases, or like the tables that we would be using today. We have IMDb movies, IMDb ratings, IMDb title principles, IMDb names and category. So IMDb movies has 8 columns, and title ID is our primary key, which would connect to IMDb ratings, which has the same primary key as IMDb movies. So IMDb title ID would act as a foreign key here. And again, it is connecting to IMDb title ID, which is again a foreign key. And here, the IMDb title principles is connecting to IMDb names, to the primary key of IMDb names with the foreign key IMDb name ID. So it is connecting to category table with the category ID, that is the primary key of the category table. The category ID in the title principles tables is a foreign key. So I hope that concept is clear, and these would be the tables that would be using for the rest of the session. Now coming to the important part, data query language. Data query language is used to communicate with the database, to query the database and retrieve data from the database. Select is the most important like the select query is the most important thing when you are learning SQL. This is the SQL statement in like most simple form. Select column 1, column 2 from table name. So that's simple, right? You can select IMDb title ID, column name, title, another column name, production company, another column name from IMDb movies. This is the simplest. This is a select query in its simplest form. Or you can use a star when you want to select every column names from every possible column names from the table. So I can just show a demo. I can provide these tables, the queries later, maybe after the workshop. I think that would be possible. So we have just open a new query window and we can select star from IMDb movies. And you can run the query by clicking F by using the key F5, or this is the run button. We can click on that. So this is all the data that is there. So just remember, this is not the entire IMDb movies data set. It is just 25 rows of it, because I wanted this to run smoother. So I'm using only a bit of it, but you can always experiment with the whole database. So I'm sorry, the tab was not available for me. So that is how you select things from a table. Going back, filter conditions. Filter conditions are very important when you are dealing with data. Most of the time, you won't need the entire data. You would need a portion of the data, which can be accomplished by using a filter condition. So here is a simple example of how to use filter condition. Select the column names from IMDb movies, where this part is the initial query that we wrote. So we don't need the entire data set. We just need the movies which came out after the year 2000. So if we put a where clause saying where year is greater than 2000, we would get all those movies which are greater than 2000. So coming back to our query, if we run this, if we select and run this, click on F5 or click here, we'll see all those IMDb title ID, title name, and production company, which all came out after the year 2000. Or you can use, you need all the movies that came out, which is made by the company, the production company, Warner Bros. So you can just have that. Here and run the query and see all the all the movies that are by the production company Warner Bros. So yeah, and this is the example. Now the like operator, it is also very crucial when you're dealing with a lot of text data. You need all the movie names. For example, if you need all the movie names whose title begins with a the. So this is the format that you can use, and you can go to you can just type out title like inside inside quotes. You can put a percentage sign and put the, and if you run this, you will get all the movie names which starts with the. You have to put the percentage sign at the end of the word to get the word in the beginning. If you put on both the sides, you will get all the movies with the word the in all of the any of the type, like any of the text, like the Star Wars The Last Jedi. So the is not necessarily at the beginning, it's in the middle of the the movie name. So you will find it like that. And if you want to find something in the end, you can just put the percentage sign in the beginning of the word. So there is nothing that ends with the. And the thing that you are putting inside the quotes in SQL is case sensitive. All the other things like the commands, the select, the column names, everything is case insensitive, but it is always easier to follow a certain guidelines to get. But whatever you put inside the single quotes is um, case sensitive, so we need to be careful of that. If we just put THE instead of capital THE, nothing is there because we need a capital T. Every movie has something with a capital T. Every movie that I use in this data. So yeah. Now the other most important thing is order of execution. So even though if we write in select from where, that order, the order that the tool executes this query is from where and select. So this is one of the most important things when it comes to writing a query. Many people run into issues because they don't know the order which the query is executed. So always look into the from clause. What are the tables that you want to hit? And then go to the where clause. So what all filters do you want to get for the particular data? And then only use the select, like what are the things that you want to display. So if you go in this order, SQL will be more easier and more easier to understand. So yeah, this is so from IMDb movies. So the compiler hits the IMDb movies first, and then it goes to the where condition. Then only it comes back to the select query. So if you think this way while writing a query, that it would be very helpful. Using multiple tables, we can just use a comma in the from clause to hit multiple tables. So yeah, so like this. So when we run this, we get an error saying that IMDb title ID is ambiguous. That is because we both these tables, IMDb movies and ratings, have the column IMDb title ID, and we don't know which table necessarily they are looking into. So we need to use an alias for the table names. We can just use an alias for the table name as IM, and we can use IR as an alias name for IMDb ratings. And to the column in question, we can put IM dot. That is how you reference a table. And so you would get things from IMDb title ID and title from IMDb movies, because title is only there in IMDb movies. But there's an issue when we do this. Every possible combination of title ID and title comes up without that is because we are not using a key to join these tables. In that case, we will have to join the tables based on a key, based on the foreign key, which I was explaining earlier, so that we can avoid this issue. Now, if I just run this after joining, you will see 26 movie names, which are present in the table, and the ratings for that from the IMDb ratings table. So going back to the slide, yeah, that's how you reference. You can just name your table and reference in your query. Joining is to combine rows from two or more tables based on the related column between them. That is the primary key and foreign key. And here is how you can either join in using a where clause, or you can use the join conditions: inner join, left outer join, right join, or full outer join. So this is how you join a table, join a different table to the existing table in the from clause. There is a table in the from clause. You can use inner join IMDb ratings IR on title ID equals to IR.title ID. So we have IMDb movies as IM, case insensitive, so it doesn't matter, but it's always helpful to use the same case. IMDb ratings IR. So IM.IMDb title ID equal to IR.IMDb title ID, and we are joining those tables, and where the production company is Warner Bros. We can put in the where condition as well. So this will give all the ratings inside the table IMDb title ID from ratings inside the IMDb ratings table, joining with IMDb title ID to the IMDb movies table, where the production company is Warner Bros. So this is how you use multiple tables and get data from multiple tables and use a where condition. So this would be the output of that. And so there are like 4 different types of join. There is left outer join, there is right join, there is inner join, and there is full outer join. So left join returns all the records from the left table and matched records on the right table. So if there is no match in the right table would just give out nulls. For example, in IMDb movies, there are some columns which for the matching values are not present in IMDb ratings. So it would just give out a null value. These title IDs are not present inside the IMDb ratings table, so it would just give out a null value. And right join is the opposite of that. It returns all records from the right table and the matched records from the left table. So this is how it would look like. Because there are no values that are present in the ratings table but not in the movies table. It is coming like this. Otherwise, there would have been nulls here. Full join is when full outer join is when you return everything, and either in left or right, if there are nulls, it doesn't matter, but it returns everything and return null values for the columns which does not have a value, something like this. So in this is a graphical representation of how right, left, and full outer joins work. So inner join would only return the things which are common to both the tables. Left join would return everything from the left table and null values from the right table. Right join is the opposite of left join. So everything from the right table and null values from the left table. Full outer join just simply gives out everything that is common and also that is only present to right table and that is only present to the left table. Now I'll move on to aggregate functions. These are the functions which can give like the count, average, sum, min, and max. These are very important. So these are some of the examples of how you can use an aggregate function. You can count of star from IMDb movies, or you can just take a sum of total values. So we move on to aggregate functions, and I'll run these one by one. Count of star from IMDb movies will give you 26. There are total 26 rows in the IMDb movies table, so it gives 26. Sum of total votes from IMDb ratings. So in IMDb ratings, there are total number of this much number of ratings present. So average of total votes would give you something like this, which is an average of everything. That is the sum divided by total number. You can give min and max of budget from IMDb movies. So min of budget, it'll give minimum budgeted movie was this, and the maximum budget of a movie was this. Like going more deeper into this thing, if you want to get the production company who had the most amount of like worldwide gross income, I'm just running the IMDb movies table just to show you what all are present inside the table. So it has title ID, title, year, genre, production company, budget in dollars, gross income from US in dollars, and worldwide gross income in dollars. So these are the columns that I have in my IMDb table. So we need to know which production company made the most worldwide gross income in like all of the time. So we can do it in this way. We can get the sum of the worldwide gross income. So select sum of IMDb worldwide gross income from movies. If we do just this, it will give only the total sum of the worldwide income, which is a very huge amount. So if we need to see it in for each production company, you can use a group by clause. So if you do this using a group by clause, it will give you the sum of all the worldwide gross incomes for a production company. And you can see this. So inside the group by clause, you will have to put everything that is present in the sum except for the aggregate function itself. So that's one example. And it is showing a sum, so you can give a column title like this. You can run this, and worldwide gross income, I just gave this at column title, nothing else. And another thing, maybe average of all the worldwide gross incomes per company. You can do it like this. And you can make the next thing, if you want to have all the company names who had a worldwide gross income of more than $1 billion with some of their movies, you can just use the having clause, because you cannot use a where clause for an aggregate function. If you are comparing an aggregate function, you have to use a having clause. So it will give you all of the companies whose worldwide gross income was more than $1 billion. So that's that. These are some of the things that we ran now. The having clause is very important when you are using an aggregate function. Order by clause. Order by clause is very simple. If you want to order your output based on any of the columns, you can use an order by clause. So if we simply put order by production company, you will get it ordered in ascending order. 20th Century Fox, Walt Disney, and Warner Bros. You can put a descending keyword to get it in descending order of the column that is specified here. So it's come in descending order. So that is order by. You can also put the position number of the column. You can put order by 1 to get it ordered by 1. And if you put order by 2, you will get it in the increasing order of the second column, which is our sum. And if you put descending, it will give you in descending order. So that is order by. Now, yeah, that is the order by clause. Now going to case when. So case when is a very important clause in SQL. This is the syntax for that. Inside the select query, we can put case when after any of the column names, or you can put just the case when like that. So case when some column is satisfying a certain criteria, put this as an output. When another criteria is satisfied, put another thing as an output, and you can um, write as many when conditions, and in the end you can also write an else, which is like if none of these criteria are satisfied, you can give another output. So let's see how that works. Case when. So I have written a query. There is title. Case when rating is greater than 8, it should output great. When the rating is great in between 6 and 8, it should output good. When the rating is greater than 4 but less than 6, it should output okay, and so forth. So if you run this, it would give you something like this. So instead of getting the rating, which are just numbers, which might not make sense in some other context, you could use a case when statement and write things like these. So this is the syntax for a case when statement. Moving on. Subqueries. So subquery is a query that appears inside another query statement. So this is how a subquery would look like. So this is our main query, and whatever in the where condition here is subquery. So subqueries can be used inside a where condition. It can be used as a join inside the joining condition, like and it can be used in the select clause, which is something like this. So this would give us an output of the name of the production company, where the budget is the maximum of all the budgets. So if we just run this query, it will give the maximum budget. So we need the company name who has this maximum budget. I think my video got stuck. Sorry, my system froze for a moment. So it'll give you everything that is. So that is a subquery. There are many different ways that you can use a subquery, and you can check it out. So query inside a query is basically known as a subquery. So there is another thing called the common table expressions, or CTEs, which can be used with a with statement. It's a temporary data set that can be used in any part of the query that we are running. So it will only exist in that session. You cannot create a with table and use it in another session. That is not. This is just a temporary table which exists only in that session. It is different from temp tables that is used in MS SQL and stuff. So this can be used in only that session. So the syntax for that is with a table name as, and inside the brackets you can give your query, whatever it is, and then you can move on to the main query like this. So it would look something like this, with max table as this. And the main advantage of this is that you can use this subquery as, you can treat this as a table itself in your main query. So I am treating this as a table itself, budget table in my main query. So CTEs are very useful when it comes to coding multiple tables, and they are easier to read, and one of the best it's like one of the best way to apply the idea of encapsulation in this is like from object oriented programming. The idea of encapsulation is that you write a function and you can use it again and again. So it is something like this. You can define a CTE, a common table expression, and you can use a CTE any number of times inside your query. So while I was working, the discovery of CTE made my life more easier, and my code became more readable, and my code was running faster when compared to I was using a subquery. So CTEs are very good methods to, if you're writing a SQL query. So if you have like 3 or 4 levels of subqueries, which is kind of outside the scope of this workshop, using a CTE would increase its readability, and you can maintain it, and like you can extend your code in any way. So CTEs are very good. So window functions. The next thing I want to discuss is window functions. These are the examples of window functions which have like different functionalities, and you can go to postgresqltutorial.com for to get these, to find out how these window functions work. I will be discussing only a few window functions here. So yeah, some of our aggregate functions can also be used as a window function. So the difference is that while we are using these as aggregate functions, we can do a lot many things than when we are using it as an aggregate function. So I'll move on to yeah, so this is how you use an aggregate function as a window function. So what you're doing here is we are finding the average of budgets partitioned by production companies. So the same thing that we did earlier, it's the similar thing that we did earlier, found the sum of the total gross income and grouped by the production company. We can do this without using a group by, but using the window, an aggregate function as a window function has many more advantages than this. So this is one example. And the next thing, the next important thing that I want to show is a rank function. A rank function is used to rank the columns based on whatever we are putting in. So inside the order by clause. So let's go to rank functions. So rank function would give something like this. It would rank order by rating, which had the highest rating, which title had the highest rating, or we can just which title had the highest rating. It is ranking like this. So rank function is very very useful when it comes to many of the cases. My system froze. I'm sorry, my system had froze just now. So this is another example of rank function where you can partition by production company. So inside each production company, which was ranked 1. So inside 20th Century Fox, which was ranked 1, like this is in the order of descending order. So that would be the rank last. So you can partition by another column and order by one column and get a ranking like this. Now dense rank is used when you see how Enchanted is ranked 2 and Star Wars is again ranked 2 because the rating was same. But Little Mermaid, instead of rank 3, it has come to 4. You can avoid that by using dense rank. So if there are 2 3s and the next one you will get as a 4, like instead of getting a 5. Now, this is a demonstration of how to use rank tables and CTEs together. So here we need to get all the movies of each production company which had the second best rating. We can rank it and just put in a where condition saying where rank is equal to 2. If we run this, you will sorry, it's froze again. Yeah, sorry, my screen froze again. So the rank and CTEs combined, you can use CTEs to, get the ranking. I will be sharing these codes. You can try it out yourself. And by coming to an end, TCL and TCL commands are data control language and transaction control language, which is outside the scope, which is just to grant and access or revoke permissions for a particular user. You can practice SQL in all of these websites, and PostgreSQL tutorial.com is a very good website. Yeah, so that's it. Thank you. I'm sorry my screen had froze sometimes in between. I'm sorry if something was not clear. Any questions?
Thank you so much for a great introduction to SQL. So one question from the chat would be, can you compare the speed of Python and SQL as far as making queries or doing these kinds of operations?
Okay. I would say yes. Python might be faster than when it is when we are using SQL, but SQL is more easier to create codes, create queries and stuff, and also you can integrate SQL with Python, which makes it a bit more faster. So you can integrate SQL with Python. So, yeah.
That makes sense. And I'll ask one more question, and then there's a lot more you can reply to on your own. So one is, how would you handle situations where there might be like different capitalizations, like capital the versus lowercase the? Do you have to have different queries for each?
Okay, so in that case, you can use put an or, like you can give an or, like where the title name starts with capital the, or title name starts with capital and small t. You can put an or and then get it done.
Okay, great.
Yeah,
that makes sense. Yeah, and so you have different more questions in the Q&A and also in the chat itself. So feel free to answer those.
Sure.
And thank you so much for the workshop.
Thank you so much.